Hello everyone. So today we're going to start chapter 5, and our first lesson is going to be on modeling factors. Factors are two numbers that when multiplied will give us another number. Okay? Or to find a product. So when we multiply two factors, we get a product. And so for instance, they're telling us every whole number greater than 1 has at least two factors. That number and 1. So for instance, 18, two of the factors have to be 1 and 18. 7 has to be 7 and 1. 342 would be 1 and 342, so on. Okay, but many numbers can be broken into factors in different ways. So they have more than two factors. And so in this activity, we're going to model and record factors of 24 for this activity. And so this kind of, if you have tiles, that'd be great. If you have marbles, toothpicks, beans, cubes like I'm going to use, but 24 something. Okay, and we're going to use all 24 tiles to make as many different arrays as you can. You'll remember from third grade, an array is something that has the same number of objects in each row. So like if I say a 3 by 8, that means I have 3 rows of 8. Okay, so we're going to do 24, and we're going to put them in as many different ways as we can. Well, we know from the directions, the first explanation, that every number greater than 1 has at least two factors. So I can list or separate 24 into just one long row of 24. And let me zoom out so you can see that. Okay, so I'm just going to make one long row of 24. And actually it's longer than my book. So maybe we should go tall. It doesn't matter which way we go. We could have 24 rows of 1 or one row of 24. Okay. So it's probably a little harder to manipulate the little square cubes than it is tiles. But that's what we have. And so that's what we're going to work with. All right. So we have one row of 24. Okay. And so I'm going to say 1 times 24. Okay. I could also turn it this way, and it'd still be the same thing. I still have 24. A product of 24. Okay, so let's try 2. Can I make rows of 2? 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Yeah, we can make 2 rows of 24. So 2 times 12 is 24. How about 3s? Can we try 3s? Let's see. 3, 6, 9, 12, 15, 18, 21, 24. So yes, I can make 1, 2, 3, 4, 5, 6, 7, 8. I can make 3 rows of 8. So how about 4? Can I do 4? 4, 8. They keep moving around on me. All right, so 4, 8, 12, 16, 20, 24. So I used all of them equally. So, and I have 4 rows of 6. So I could actually have another one that's 4 times 6, 24. Now let's say if I try 5. Okay, I want to show you one where it won't work. Okay, so there's 5. And then we'll go 10. 15. 20. And then you notice we only have 4 left. I can't make another row of 4. So 5 is not a factor of 24. Okay. So, and then we start repeating over. We have 6 and we have 8. Okay, so on. So use all the tiles to make as many different arrays as you can. Record the arrays in the grid. So we had one row of 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Clearly we could have counted by more than one at a time. Okay. So this is a 1 by 24, or 1 times 24. This one here is depicting 2 by 12, 2, 4, 6, 8, 10, 12. 3 by 8. And we also had a 4 by 6. So those are all different ways we can make 24. So these are all the different factors of 24. So 1, 24, 2, 12, 3, 8, 4, 6. So the factors of 24 from least to greatest are 1, 2, 3, 4, 6, 8. 1, 2, 3, 4, 6, 8, 12, and 24. Okay. 2 factors that make a product are sometimes called a factor pair. How many factor pairs does 24 have? So there's 1, 2, 3, 4. 4 factor pairs. The pairs are 1, 24, 2 and 12, 3 and 8, 4 and 6. Okay. All right, so those are factors. Number 1, use the array to name the factors of 12. Well, so this is one row of 12. So one factor pair is 1 and 12. This one is showing me 4 and 3. Or I could say 3 times 4. It doesn't matter. The factors are 4 and 3. 2 and 6. So the factors of 12 are 1, 2, 3, 4, 6, and 12. Use tiles to find all the factors of the product. Record the arrays and write the factors shown. So if we have 5, okay, can I put them in one row of 5? Well, certainly I can, because every number has 1 as a factor. So I can do 1 times 5. All right. Now let's try 2. Can I put 2 in a row? 2, 4. No, I have an extra one left over, so no, 2 won't work. How about 3? 3, no, that won't work. How about 4? 4 and no, that won't work. 5, yes, that works. Definitely can't do 6 because I only have 5. So we only have 1 and 5 as factors for 5. 20, so we have 5, 10, 15, 20. All right, so let's see. So I know we're going to have 1 in 20, right? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we know we have to be able to do 1 times 20. Now, how about 2? Well, 2 works. Let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and I have nothing left over. So yes, we have 2 rows of what? 2 rows of 2, 4, 6, 8, 10. So 2 rows of 10. Threes. Can we do threes? 3, 6. You'll start to see that when I say 3 as one of the factors, basically I'm using the multiples of 3. And if I don't say 20 when I'm using the multiples of that factor, it's not a factor of the larger of the number. So we're counting by 3s right now. And I noticed that when I got to the end, I have 2 left over. So 3, 6, 9, 12, 15, 18. I don't say 20. So 3 is not a factor. Okay. 4. Would you say 20 when you count by 4s? I think you would. 4, 8, 12, 16, and 20. So yes, we do. So 4 is a factor, and we counted 4. There's 4 rows of 5. So we put 5 into each row. And in 5, we do know already works, okay, because I could have done 5 by 4. 6, will 6 work? So 6, another 6 is 12. And another 6 is 18. But that's not going to work because that leaves me 2 left over. So 6 is not a factor of 20. And besides, when I go 6, 12, 18, I don't say 20. 7, well, so that means we're adding 1 more to each row, right? And so I'm at 7, 14. Do I have 7 left? 2, 4, 6. No. So when I skip count by 7s, I go 7, 14, 21. I don't say 20. When I skip count by 8s, so now we have 8 in each group, and I have 4 left over. 8, 16, 24. 8's not a factor. 9, if we put 9 in a group, now we have 18. So I had 9, 18, 27. That doesn't work. If I say 10, that would work, but we already got 2 times 10. Okay, so those are the factors of 20. So we have 1, 2, 4, 5, 10, and 20. So there's 6 factors for the number 20. Okay, let's try 25. So we had 24 to start, so let's do 25. And again, we know 1 and a row of 25 would definitely work. 5, 10, 15, 20, 25. Will 2 work? So let's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I got 24 and I have 1 left over. So 2 is not a factor. And that makes sense because 2, when I count by 2s, it always is an even number. 2, 4, 6, 8. So 25, I should have known right away that that wasn't going to work. 3, well, I know that when I count by 3, I am going to show this using the cubes, but 3, 6, 9, 12, 15, 18, 21, 24. I don't say 25 when I skip count by 3s. So 3 is not a factor of 25. There's no way of multiplying 3 by a whole number and getting 25. So in fact, I get 8 rows of 3 evenly, but there's still 1 left over. So 3 rows of 8, that won't work. If I made it 4 into each group, well, 4 times 6 is 24, but again, I have 1 left over. So 4 is not a factor. 5, how about 5? We should know that any number that has 5 as a factor has to have a 1s that ends in 5 or 0. So 25 will be a multiple of 5. So 5 is a factor of 25. And it should be a 5 by 5, right? So it should make a square. Okay, 2, 4, 5, 2, 4, 5, 5 rows of 5. So that works. Six, we already did when we did 4 times 6 is 24. So we know 6 won't work. 7, 14, 21, that won't work. 8, 16, 24, that won't work. 9, 18, 27, that won't work. 10, 20, that won't work. 11, 22, 33, that won't work. So we're basically, that's it. So now here, in this case, we're list 1, and we only list 5 once. It's the same factor. So 5 is a factor of 25, and then 25. So if 25 only has 3 factors, whenever the whenever the factors are the same that give you the product, you list it once. All right, so now let's move on. Use tiles to find all the factors of the product. All right, so 9. So if we have 9, 2, 4, 6, 8. All right, so that's 9. Okay, I'm going to use some grid paper on this one just to draw them in. We know that 1 times 9 works, right? So that's our 1 times 9. 2, I'm going to show 2, but 2 is not going to work because 2 has to have a multiple of an even number. And so when I count by 2s, I have 1 left over. So 2's not. How about 3s? 3, 6, 9. Yes. 3 rows of 3 definitely work. 3. Okay, if we go 4 by 4, that gives me 8, not 9. So 4 doesn't work. 5, I'm certain won't work because 5, a multiple of 5 has to end in a 0 or a 5. 9 does not end in 5 or 0. 6, no, because I could have a row of 6, but there's going to be 3 left over, right? So there's 6 rows of 1, but I have 3 left over that I can't share. So that won't work. 7 is the same situation. Okay, there's 7, and I have 2 left over. I could go 8, and that leaves me 1. I go 9, well, already forgot that. So the factors of 9 are 1, 3, and 9. Okay, 21. All right, so there's 21, and we know 1 times 21 will work. I didn't even think I have 21 squares here, though. All right, so we know 1 times 21. I'm just going to go ahead and say 1 times 21. I didn't have 21 squares on my grid paper. Okay, but 1 and the number is always a factor of a number larger than 1. All right, so 2. Will 2 work? I'm not going to count 2. I'm not going to try 2 because 21 is not even. So 2 is not a factor of an odd number. 3. Well, we can try 3. 3, 6, 9, 12, 18, 21. So we have 3 in a row, 3 rows of 1, 2, 3, 4, 5, 6, 7. 3 rows of 7. And 3 times 7 is 21. Okay, 4, I'm going to just skip counting in my head. 4, 8, 12, 16, 20. 4, 8, 12, 16, 20. Did you notice that 4 also ends in even numbers? So 4 is not a factor of 21. 5, no, because 21 doesn't end in a 5 or a 0. 6, I don't think so. Well, let's try 6, 12, 18, 24. 7, we already have 7. 8, 8, 16, 24, 32, 40. What do you notice about 8s? They also had multiples that are even, so 8 won't work. 9, 9, 18, 27. Nope. 10, 20. Oh, 10s. They always have to end in a 0, huh? No, so it's not, can't be 21's not a multiple of 10. 11. 11 and 11, that's 22. Oh, no. 13. Well, that's, no. 14. No. Okay, so that's it. 1, 3, 7, 21. All right, number 7. Now, 17 is what we call a prime number. The only 2 numbers that are factors of 17 are 1 and 17. 2 we already know won't work because 17 is not even. 3, 3, 6, 9, 12, 15, 18. So 3 won't work. 4 we already said has even multiples. 5 doesn't end in 5 or a 0. 6, 12, 18. No. 7, 14, 21, no. 8, 16, 8 we said has to have an even multiple. 9, 18. So that's it. There's the only factors that'll work for 17 are 1 and 17. All right, and then 18. Well, 3, 6, 9, 12, 15, 18. All right, well, we have an array of 18 right now. That's a 3 by 6. So 3 times 6 works. We know 1 times 18 works. I don't even have to draw that out, okay? I know 2 will work because 18 is even. So how many rows of 2 should I have? I should have 9. 2 times 9 is 18. Okay, let's just prove that. Okay, I've used all the cubes and I have 3, 6, 9. So a 2 by 9. Okay, how about 4? Would 4 be a factor of 18? 4, 18 is even, so maybe. 4, 8, 12, 16, 20. Oh, no. 5? No way, because 8 doesn't end in a 0 or a 5. 6. Oh, we already got 6. All right. 7, 14, 21. No. 8. Could be, because 8 has to have a multiple that's even. 8, 16. Oh, no. 24. No. 9, we already have 9. All right, so those are our factors for 18. So we have a factor pair of 1 and 18, 2 and 9, 3 and 6. So listing them in order, we'd have 1, 2, 3, 6, 9, and 18. All right, let's move it on. Let's move on. Pablo is using 36 tiles to make a patio. Can he arrange the tiles in another way and show the same factors? Well, same factors. So right now he has 9 rows of 4. What if he did this? What if he had that instead? Now he wouldn't have 9 rows, he'd have 4 rows of 9. So sure, he could change it around and make, and I'm not going to draw all the little squares in. So I'm going to show 4 by 9. 4 rows of 9 instead of 9 rows of 4. So it's the same amount, but it's oriented different. Okay. And it says, explain. Okay, so 4 rows of 9 tiles would look different than 9 rows of 4 tiles. All right, so number 10. How many different rectangular arrays can Pablo make with all 36 tiles so none of the arrays show the same factors? So if we go back to our facts here, we know 1 times 36, right? Okay. So they don't show the same factors. 2 we know will work because 36 even. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. 18 times. 3 will also work. 3 times 12 is 36. 4 times 9 is 36. We already know that. 5 won't work. 6 times 6 is 36, so that will work. And then we start repeating these. So how many different rectangular arrays? He can make 5 rectangular, or you can make 5 rectangular arrays. If 6 is a factor of a number, what other numbers must be factors of that number? If 6 is a factor of a number, what other numbers must be factors of that number? So let's think about that, right? If 6 is a factor of a number, well, we know 1 has to be the factor, right? 1 and 6. What else makes 6? 2 does, right? 2 and 3. Well, that would be it then. So if 6 is a factor of the number, then those are the only other 3 possibilities. 1 times 6 and 2 times 3. Number 12. Jean spent $16 on new t-shirts. If each shirt cost the same whole dollar amount, how many could she have bought? So this is asking us all the different factors of 16. She could have bought one shirt that cost $16. She could have bought 2 shirts that cost $8. She could not have bought 3. 3, 6, 9, 12, 15. We don't say 16. 4. She could have bought 4 shirts that cost $4 each. 5, she couldn't have. 5, 10, 15, 20. 6, 12, 18. No, she couldn't have bought 6 shirts. 8 shirts. She could have bought 8 shirts that cost $2. And she could have bought 16 shirts that cost $1. Why didn't I list 4 again? Because this is the same exact thing, right? So how many could she have bought? She could have bought 1, 2, 4, 8, or 16 t-shirts. And 13. Carmen has 18 connecting cubes. She wants to model a house shaped like a rectangle. If the model has a height of 1 connecting cube, how many different ways can Carmen model the house using all 18 connecting cubes? What do we need to know? Well, we need to know the question. How many different ways can Carmen model the house using 18 connecting cubes? Okay, so how is finding the number of ways to model a rectangular house related to finding factor pairs? Well, we have to figure out how to share the cubes equally for the different levels of the house, right? So each model has to have 18 cubes, so it will some combination of the factors of 18. Why is finding the factor pairs only the first step in solving the problem? Okay, so she's making 18. She has 18 cubes. She wants to model a house shaped like a rectangle. All right. So if we only do that, it's asking if we only find the factor pairs, we'd have to answer. If I listed just the factor pairs, that doesn't answer the question of how many different ways. So listing Okay, so what I'm trying to explain here is that if I say 1 times 18, we know that that is a factor. But would a row of one row of 18 look different than 18 rows of 1? Would the house look different? Well, it should, right? Okay, so what we're going to do is we're going to list the factors of 18. List the factor pairs of 18. So we know 1 times 18. I know 2 will work because 18 is an even number. I know 3 will work. 3 times 6 is 18. 4 will not work. Okay. 5 will not work. 6, we already know works. 7 won't work. 7, 14, 21. 8 won't work. 8, 16, 24. 9 works. And 18 works. So the factor pairs for 18 are 1, 18, 2, 9, and 3, and 6. But how many different ways are there? You know what? So I was checking the teacher notes on that one, and it says 3 ways. Well, there are blank ways Carmen can arrange the cubes to model the house. So yeah, if we just look at factor pairs, there's 3 ways listed here. And so if we have 1 row of 18 and we have 2 rows of 9, so 1 row 18 and we have 3 rows of 6. Would they look different if you changed the orientation? I guess in a sense they would look exactly the same. They would be positioned differently in space. So based on factor pairs, there are 3 different ways. If you want to look at would they look differently, I think they would, and so I would say 6 ways. But if we're just based on factor pairs, there would be 3 ways. All right, 14. Sarah was organizing vocabulary words using index cards. She arranged 40 index cards in the shape of a rectangle on a poster. For 14A through 14E, choose yes or no to tell whether a possible arrangement of cards is shown. So we're looking for factor pairs of 40. Is 4 rows of 10 40? Yes. Is 6 rows of 8 40? No, that's 48, so no. Is 20 rows of 2 40? Yes. 2 rows of 2 sets of 2 10s is 40. 40 rows of 1 card? Yes. 35 rows of 5 cards? No. Okay. So that's it for lesson 5.1 on factors. So basically, when we think of factors, we think of 2 numbers that when they multiply together will give me the product of that number that we're looking for. Like 18. 1 times 18 is 18. 2 times 9 is 18. 3 times 6 is 18. So on. So until our next lesson, which is on factors and divisibility rules, may the numbers always be in your favor.